The model used here to illustrate at-risk's basic features is of a company that is planning to develop an e-commerce service. There is no marginal cost of providing the service, but a server facility must be constructed, which will require an upfront investment for each unit of annual capacity. The unit cost of capacity is assumed to be 80 cents, and the revenue per transaction is assumed to be $1. The new service is a fad, expected to be popular for only 1 year. The transaction demand for the year of business is uncertain, but the company's best guess is a demand of 2 million transactions. Therefore, the company must decide how much capacity to build for this single year of business. If it builds more capacity than demand, the extra capacity will be wasted. If it builds less capacity than demand, it will lose potential sales. To get started, here is a deterministic version of the model, which assumes no uncertainty in transaction demand. Any demand could be entered in the demand cell, but the number used here is the company's best guess, 2 million. Also, any capacity could be entered in the capacity cell. The current value plans capacity for the best guess of transaction demand, and this is a good choice for the deterministic model. But there is no guarantee that it is best for a model assuming uncertainty in transaction demand, as you will see shortly. The logic of the model is very simple. Capacity cost is 80 cents times the capacity used. Revenue is $1 times the smaller of capacity and demand. And profit is revenue minus cost. It is important to realize that there is an asymmetry in the model. To see this, I will enter a demand greater than capacity and a demand less than capacity. When demand is greater than capacity, the company receives revenue only on its capacity, and the extra demand is lost. So the profit is the same for any demand greater than capacity. However, when demand is less than capacity, the company receives revenue only on its demand, and the extra capacity is unused. In this case, profit decreases as demand decreases. This means that the most profit the company can earn with this capacity is $400,000. But it could earn a lot less if demand is small. Now, starting with this deterministic model, I'm going to develop an at-risk model that explicitly incorporates uncertainty in transaction demand. As I go through this demonstration, I will follow the typical steps for developing any at-risk model. Before you can use at-risk, you must load it into memory. This is easy. It can be done with Excel already open, or it can be done with Excel not yet open. In the latter case, opening at-risk opens both Excel and at-risk. In either case, go to the Windows Start button, find the Palisade Decision Tools group in the list of all programs, and select at-risk. Of course, you can also have a shortcut to at-risk on your desktop or your taskbar. As you can see, it usually takes a few seconds for at-risk to load. You may get messages like this one. And eventually you will see an at-risk welcome window. Once you close this window, you will know that at-risk is loaded because you will see this at-risk tab for its ribbon. By the way, you can see that I am using at-risk 6.0 for this video. If you have used only earlier versions, you will see a few changes in the basic modeling tools, but nothing dramatic. To unload at-risk from memory, you have two choices. If you close Excel, at-risk will close as well. Alternatively, you can click the Utilities drop-down of the at-risk ribbon and select Unload at-risk add-in. This unloads at-risk but keeps Excel open. I won't actually close it, but here's how you would do it. Now that at-risk is open, I will walk you through the steps of developing the at-risk e-commerce model. Step 1. Decide which inputs are uncertain. In this case, I assume that only transaction demand is uncertain. The other inputs, the unit cost of capacity and the revenue per transaction, could also be treated as uncertain, but for this beginning application, I will assume that these two inputs are known to be 80 cents and $1 respectively. Step 2. Choose a probability distribution for uncertain transaction demand. This step requires you to think carefully about the uncertain transaction demand and choose a probability distribution that correctly encodes your knowledge and beliefs about the uncertainty. For this example, a normal distribution with mean 2 million and standard deviation 500,000 is chosen, but others could be chosen. This is a subjective decision, and there's typically no right answer. To enter this probability distribution in the transaction demand cell, you could enter the formula directly, just like you enter other Excel formulas. But an easier way is to let at-risk help you through its Define Distributions button. To do this, you first choose the distribution you want, in this case normal, and then enter its parameters, in this case the mean and standard deviation. As you can see, at-risk's risk normal function has been entered in the green demand cell. The risk static part is entered automatically for you. It indicates the value, 2 million, that is shown in this cell when the following setting is toggled to static. Specifically, look at the dice button in the at-risk ribbon. This is a toggle. It's either white or orange. By default, it is toggled to white or static. In this case, at-risk shows the mean of the distribution in the uncertain cell. So if you press the F9 key to recalculate with new random numbers, nothing happens. If it's toggled to orange or random, which I will do now, the uncertain cell really looks uncertain, in the sense that if you press the F9 key, you can see many different scenarios. You can decide which setting you prefer. But one advantage to the static setting is that you see the results from the deterministic model. Fortunately, the setting has no effect when you eventually run the simulation. Step 3. Choose values for any decision variables. In this model, there is only one decision variable under the company's control, transaction capacity. For now, a reasonable value, 2 million, will continue to be used, but it will be varied later on to find a value with better profit potential. Now is a good time to save your work. Although this isn't really a step in the at-risk process, you should always remember to save frequently. Step 4. Develop the logic of the model with Excel formulas. This is typically where you spend a lot of time. However, this has already been done for you in rows 13 to 15. In fact, the logic is exactly the same as in the deterministic model. However, because the revenue and profit cells depend on the uncertain transaction demand cell, they change when demand changes, as you can see by pressing the F9 key, assuming that the dice button is toggled to random. This is the essence of simulation. When uncertain inputs change, outputs change, so that you can see many different scenarios, not just a single best guess scenario. Step 5. Choose one or more at-risk output cells. As you have already seen, if you press the F9 key, you get new outputs, such as new profit values. The trick is to keep track of these values as the model recalculates over and over. This is where you really appreciate the power of at-risk. It allows you to designate output cells of interest. Then when the simulation runs for hundreds or even thousands of recalculations, at-risk keeps track of the values in the designated output cells, and it eventually lets you see these results in many different ways. To designate any cell as an at-risk output cell, select the cell and click the Add Output button. At-risk will suggest a label for this output, which it uses later in reports. You can change this label if you like. For this model, I have designated only one output cell, the profit cell, but in general, you can designate as many as you want. Note that the formula has changed to include risk output and empty parentheses and a plus sign. This is at-risk's way of indicating that this cell is an at-risk output cell. It has nothing to do with addition. Step 6. Change at-risk settings. There are many at-risk settings you can change from the Simulation Settings button. However, you typically need to change only one setting, the number of iterations. This is the number of recalculations or repetitions that at-risk generates. You should choose a reasonably large value because you get a more accurate estimate of output distributions with more iterations. The only downside to a large number of iterations is increased computing time. For practical purposes, from 1,000 to 5,000 iterations is generally sufficient. You can change the number of iterations from this dialog, or you can change it directly in the iteration box right here. By the way, I changed one other setting. I chose a fixed random number seed of 123, although any other number would work. You will typically want to choose a random seed. But I chose a fixed seed so that if I needed to redo parts of this video, I would get the same results each time. If you choose a random seed, you will get different results each time you run the simulation. Step 7. Run the simulation. This is the easy part. Just click the Start Simulation button, and although it is not visible here, you will see a progress indicator at the bottom of the screen. Depending on the complexity of your model and the number of iterations you request, the runtime can be a few seconds or considerably longer. Also, depending on which cell is selected in your simulation settings, you might see a distribution being built as the simulation runs. Specifically, depending on whether this button is orange or white, you might see a window showing a histogram being built. You might find this annoying. So if you don't want to see any simulation results as the simulation is being run, you can toggle this button to white. The simulation results will still be available, but only after the simulation runs. Again, this is a good time to save. However, once you have run an at-risk simulation, you are asked whether you want to save at-risk simulation results and graphs. Either response is fine, but you should understand the two options. If you respond yes, the simulation results will be saved with the file, and they will be available the next time you open the file. However, this can sometimes add significantly to the size of the file. On the other hand, if you respond no, the size of the file will remain unchanged, but you will have to run the simulation again the next time you open the file. Step 8. Analyze the resulting output distributions. This is the whole point of the simulation. You want to see how an output such as profit varies as one or more uncertain inputs vary. Therefore, at-risk provides multiple ways to view output results. I will show the basic possibilities here, and there are variations of these you can explore on your own. The easiest option is to select an output and click the Browse Results button. This shows a histogram of the selected output, together with many summary measures on the right. By the way, you might have noticed that many more summary measures are shown in version 6.0 than in earlier versions. There are also sliders you can move. For example, if you move the left slider to 0, or if you type 0 at the top, you see the fraction of iterations where profit is 0 or less. So with this capacity, the company stands about a 21% chance of losing money. The main takeaway from this histogram is the skewness to the left. This is in spite of the symmetric normal distribution of transaction demand. The most profit the company can make is $400,000, and this is a fairly likely outcome that occurs whenever the transaction demand is greater than or equal to capacity. It's this bar right here. However, the company can also lose a considerable amount of money when transaction demand is low. This chart is quite interactive, and At Risk provides a lot of options for changing it with its buttons below the chart. You can experiment with these. For example, you can click the third button from the left, select Copy Graph, and then paste it in the Excel. The sliders no longer work, but at least you have a picture of the distribution. You can also browse the distribution of an uncertain input, such as transaction demand, but this shouldn't provide any surprises. You already specified a normal distribution for this input, so this is what you see. A second option is to click the Summary button. This shows summary measures of all designated outputs on one tab and inputs on another tab. The summary measures include a mini histogram, the mean, the minimum, the maximum, and 5th and 95th percentiles. If you want more summary measures, you can right-click and select Columns for Table. For example, I will select Standard Deviation and Median. As with Browse Results, there are a number of buttons at the bottom that you can use. Again, they are quite straightforward. For example, you can select the third button from the right, select Copy, and then paste it into the worksheet, although there are better ways to get the results in the worksheet. The results you get from the Browse Results button or Summary button are great, but they disappear when you close their windows, unless you copy them into Excel as indicated earlier. To get more permanent results, you can click the Excel Reports button. However, before I generate a report, you should understand where it goes. By default, At Risk stores reports in a new workbook, not in the same workbook as your model. If this is not the behavior you like, you can change an At Risk application setting. To do so, click the Utilities drop-down and select Application Settings and change Place Reports In setting to be Active Workbook right here. This setting will stay in place for all future at-risk models until you change it again. Back to Excel Reports, you can see that there are many options and you can experiment with them. However, the top option, Quick Reports, is probably sufficient for most of your analyses. This generates a new worksheet, and on the left there are several charts including the histogram you saw earlier and a cumulative probability distribution, plus a lot of summary measures to the right. There are times when you might also want output results to be stored in Excel cells, and At Risk allows you to do this with its statistical functions, such as risk mean, risk percentile, and others. If you want to learn about these or at least see the possibilities, you can click the Insert Function button and select the Simulation Results group. These are the statistical functions you can use. Each statistical function calculates a summary measure of an output distribution. For example, risk mean applied to profit calculates the average of all profits generated during the simulation. Note that you can enter these functions in a worksheet at any time, but their values will not be meaningful until you run the simulation. Therefore, don't be surprised if these functions show unrealistic values or even generate errors. The appropriate values will appear once you run the simulation. Several at-risk statistical functions have already been entered in the model. I painted them white to hide them, but now I'll paint them black. Here are some examples. The risk mean function returns the average of the profits. The risk standard deviation function with 2 D's returns the standard deviation of the profits. The risk percentile with second argument equal to a decimal number from 0 to 1 returns the requested percentile of the profits. For example, if the decimal is 0.05, you get the 5th percentile. The risk target function, with second argument equal to any potential profit value, returns the fraction of profits less than or equal to this value. For example, if the last argument is 0, you get the fraction of profits that are 0 or negative. If you want a greater than fraction, you can subtract risk target from 1. For example, here is the fraction of profits greater than 200,000. Also, note that the fraction of profits greater than 400,000 is 0, because such profits are impossible with a capacity of 2 million. Two other buttons you might want to try are the Detailed Statistics and Simulation buttons. Detailed Statistics, Simulation Data. The Detailed Statistics provides about all the summary statistics of the outputs and the uncertain inputs you could ever want. These appear in a separate window, but if you want them in your workbook, you can click the middle button at the bottom and copy them or get a report in Excel. The Simulation Data button provides data on all uncertain inputs and outputs for each of the iterations you ran. So in this case, there are 5,000 rows in this table. Again, you can move these into your workbook quite easily if you want them. Step 9. Perform sensitivity analysis. Once a simulation model has been developed, it is always a good idea to use it as a tool for sensitivity analysis. At-Risk lets you run a number of sensitivity analyses, some of which are rather advanced, but I'm going to describe only one type, which is probably the most popular type. This analysis asks the following question. If a model has several uncertain inputs and a specific output of interest, which of these uncertain inputs has the greatest effect on the output? To answer this question, At-Risk provides a tornado chart, where the uncertain inputs with the greatest effects have the longest bars and are shown at the top of the chart. The e-commerce model developed so far has only one uncertain input, so this sensitivity question doesn't really apply. To make it apply, I will change the model slightly so that the unit cost of capacity and the revenue per transaction are also treated as uncertain inputs. Again, I will use the normal distribution for these inputs, but other distributions could be used. I will also paint them green. This isn't really necessary, but it is my convention for indicating that they contain at-risk probability distributions. Now each of these three sources of uncertainty has some effect on profit, but which has the most effect? To see, the simulation can be run for 5,000 iterations to generate the histogram of profits you have seen before. This time, however, each iteration uses different random values of each of the three uncertain inputs. You can now click the tornado button. You get several choices. Although they all lead to similar results, the correlation item is a good choice. Each bar in this graph shows the correlation between profit and the corresponding uncertain input. As you can see, the largest correlation is with transaction demand. The correlation is fairly strong at 0.77. When demand is large, profit tends to be large, but when demand is small, profit tends to be small. The other two uncertain inputs have much smaller correlations with profit, 0.42 and minus 0.28. Of course, the negative correlation between profit and cost of capacity is expected. When the cost of capacity increases, profit decreases. But the main takeaway from this chart is that transaction demand has the largest effect on profit. Starting from this tornado chart, you can also see scatter plots of profit versus each of the uncertain inputs. So this is an alternative way of seeing how uncertain inputs are related to profit. There's the scatter plot between profit and transaction demand as an example. By the way, you can also run these sensitivity analyses directly from the Tornado button in the results group, this button right here. Step 10, finding good values of decision variables. One important goal of this e-commerce model is to find a transaction capacity with good profit potential. Which values should the company use? Of course, the company wants to choose a value that has good profit statistics, a large mean, a small standard deviation, a large 95th percentile, and possibly others. This is a difficult choice, and there might not be a single value of capacity that works best for all of these goals. However, At-Risk has a very useful function, Risk SimTable, that lets you test different capacities to see their effects on profit. To use this function, you first decide on the capacities you want to test. You can test as many as you like. Here, 6 possibilities will be tested. Then in the blue decision cell, you enter the Risk SimTable function, not a value, where the argument is the list of values you want to test, enclosed in curly brackets. Note that At-Risk shows the first of these, 1.2 million, in the blue cell, but when you run the simulation, it will test all 6 of them. Before running the simulation, you have to change one simulation setting, the number of simulations. You should change this to the number of capacities you want to test, in this case 6. Then At-Risk will run this many separate simulations, each with the number of iterations specified, here 5,000, and it will use the same random numbers in each of the 6 simulations. This latter point is important. It means that one capacity won't win the contest simply because it got lucky random numbers. Now I will run the simulation. All of the output reports discussed earlier are available for each of the 6 simulations. This lets you make comparisons. For example, if you use Browse Results, you can click the button with the pound sign to see any of the 6 profit distributions. Or if you click the Summary button, you see summary measures for all 6 of the simulations. If you produce quick reports from the Excel Reports button, you get a separate worksheet for each of the simulations, as shown next. Finally, if you like to use the statistical functions in At-Risk, like Risk Mean, you can append a last argument to any of them, the index, 1 to 6, of the simulation. I created the necessary formulas to the right and painted them white to hide them. Now I'll paint them black. Notice how I made these formulas copyable to the right by making the profit cell absolute and referring to the simulation indexes in row 16. Here's an example. And I was able to copy that to the right. Which of these capacities should the company use? The decision is still not an easy one, but using capacity equal to mean demand is certainly not a good choice. It has a low mean profit, a fairly large probability of losing money, a relatively small probability of making at least 200,000, and a large negative 5th percentile. In most respects, a larger capacity like 2.2 million is even worse. You could easily make an argument for a capacity of 1.4 million. It has a high mean, a low probability of losing money, a high probability of making at least 200,000, and a positive 5th percentile. On the downside, it has a relatively low 95th percentile. If you are concerned only with mean profit, you might instead favor a capacity of 1.6 million. In any case, the risk sim table function allows you to make a meaningful comparison across these various capacities. It is a very handy function in at-risk's arsenal, and you should get used to using it whenever possible.